Hi guys, this is Structures Explained, and in this video we are going to discuss about typical reinforcement detail in a concrete beam. Reinforcement are essential part of a concrete beam. It resists tension forces, increase the compression capacity, enhance ductility, and reduce long-term deflections in the concrete. Additionally, reinforcement prevent cracking of concrete due to shear stresses, shrinkage, and temperature stresses. First, we will see the reinforcement distribution in a single span beam, and later we will have a look at multi-span or continuous beam. In a single span beam, first we have is bottom reinforcement, which resists the beam from bending stresses. They also resist the tension cracks which occur at bottom of beam since concrete is weak in tension. They run from column to column and have a 90-degree hook at the ends to provide sufficient anchorage. In case if additional reinforcement is required by design, they are provided as second layer above the bottom layer. If more additional reinforcement is required, they are added in similar way in third layer and so on. Then comes top reinforcement, which runs from column to column and have a 90-degree hook with sufficient anchorage at the ends. Top reinforcement also resists the bending stresses produced at the supports. In case if additional reinforcement is required by design, they are provided as second layer below the top layer and are extended by 1/4 of span length from face of column or as required by design. Next we are looking at side face reinforcement. These reinforcements are generally provided to deep beams which have depth higher than 900 mm or 36 inches. This value of depth differs from code to code. Side face reinforcement run along the side of the beams and resist crack width in tension zone of concrete section. They also resist the torsional forces and resist 45-degree crack produced due to torsion. Side face reinforcement also take part in resisting axial forces along the beam. Additionally, side face bars avoid torsional buckling in deep beams and improve ductility. These bars are provided equally on both faces of the beam. Next we have is stirrups or transverse reinforcement, which resist the shear stresses in the beam and hold the longitudinal reinforcement in place. Stirrups prevent shear, flexural and torsional cracks which occur at 45 degrees to the main axis of the beam. Stirrups also add to the shear strength of the concrete. Stirrups are closely placed near the support of the beam as shear force is maximum near the supports. The closely placed stirrups must be spread to a minimum distance of 2 times the depth of the beam. But if required by design, closely spaced stirrups may be distributed along whole length of the beam. Stirrups can be classified on the number of legs they have. They can be single-legged, two-legged or four-legged and so on. Based on loops, stirrups can be open-looped or closed-loop. Lastly, based on hook angle, hooks can be 180 degree, 135 degree or 90 degree as per design requirements. This ends our single span beam reinforcement. Next we'll have a look at multi-span or continuous beam arrangement with a cantilever at the end. In multi-span or continuous beam, we have similar kind of arrangement for bottom reinforcement, top reinforcement, side face reinforcement and stirrups as in single span beam, except for the intermediate junctions where top and bottom reinforcement are extended in adjacent spans. All the extensions are governed by design, but typically the extra top bars are extended to 1/4 of span length in adjacent beam. For the cantilever beam, the top and bottom bars from the adjacent span are continued till the end of the cantilever. Here the stirrups are placed at closer spacing throughout the cantilever portion. That's it for this video guys. More such videos on reinforcement will follow on this channel, so do subscribe